to take a look at this beauty, and this is an original Commodore MPS 801 printer, and this is one of the original Commodore printer, or at least the original printers that was delivered with the Commodore 64 kind of computers. And I actually remember using one of these back in the day, and this belongs to a fellow retro enthusiast who lives nearby. And straight out of the box we can see there are some shortcomings. This is probably the power supply, so that needs some work. I can see that there is no printer ribbon installed, so I will see what we can do about that. And we will give this a dry test to see if it actually works. Yeah. Let's lift it out of the box. Some of the glue on the packaging has loosened over the years. Oopsie doopsie. It seems like the plastic parts here was not sticking. Yeah, but no damage done to this. It probably should just stay like that, and this should be like that. Okay, and what do we have here? This is a power plug of sorts, 6 amps 230 volt AC from Masterpiece England, but this is not a standard UK power supply, so we have to check that out. Back in the time when this printer was released, most of the printer, at least the ones that I came by and did service on, was needle printers, where you had 9 needles who stood on top of each other, and each of them could make a vertical dot on the paper through the ribbon. But this printer actually has a kind of different system that we will come back to later. And this is a tractor feed, for those who remember that from back in the day. And if we look into the shape of this printer, this plastic ribbon actually looks to be in good condition. Sometimes these ribbons, they just ease into some sort of floppery gunk, but this is firm and it's not sticky, so I think that's good. And the head for the hammer mechanism should be inside here, and it's very difficult for me to see how that has kept up with reality. Yeah, this is probably something that we have to test. I don't know how much we can actually test this printer without having a ribbon for it, but we might power it on and see how it goes. This printer has only the Commodore serial interface, and they have this address selector here, and it's daisy chain on the serial bus. I'm not sure if there is any self-test or any other thing on this printer without it being connected to the Commodore. Over here you have the on-off power switch, and you have some, probably there is a switch behind this for paper advanced to pull the paper forward, and you have of course the manual feed here. Yes, so the first thing we need to do is to actually get this connected to something that we can connect to 220 volt, and we do want to take a check to see what power ratings this printer has. And here it states that it's 220 to 240 volt AC, and it's an electric printer, and it's made in Japan, and it has a serial number, and as usual these Commodore serial numbers don't give any useful information, at least not for me. The rubber feet on the bottom is in quite good condition, and even though the plastic here has yellowed some, you can see behind these doors what the original color should be. This glass at least was smoky when this printer was new. To just connect this to power to check if it works, I am going to use this plug that I've used several times before to different projects, and I'm just going to stick it on easy over here just to test this, and we can make a more permanent test or buy a connector for this if it's working as it should. As I said, this is not a permanent solution, this is only for testing this. And here they actually have set us a warning. The wires in this main sleeve are colored in accordance with the following code. Blue neutral and brown is live. And we did follow the color code, didn't we? Yeah, so now for the first test. Does this power on? And I can start with the power switch. I don't know exactly. Off is that way, yes? I did hear a click, but nothing else. There should probably be a power LED under here. Oh, this again, I don't think any of these matters for turning this on. It appears totally dead. Okay, so our first priority is to take this apart and see what's happening. But this and the fact that it actually is missing the power plug is a strong indicator that someone has been inside here before. So we have to see what we find out when we open this. It's always easier to clean up your own mess than somebody else's. So I just disconnect this and see what we have to do to get this open. There are some screws here, I notice, on the top. And we try with my trusty yellow screwdriver. It's actually starting to rain quite hard on the steel corrugated roof. And none of the screws is sticking to the magnetics on this screwdriver. Oh, things are falling apart. There was this front cover come loose. Take this out and this, and we're in. And what do we have in here? Yeah, at least we have a fuse. And I'm just going to give that fuse a quick check with my old Metex. As we saw on an earlier video, this display is not very good for showing on camera, but I will just test the fuse and see. And we disconnected the power cord, so this should be totally safe. Yeah, and the fuse is blown. So that means that we at least have one other fault in here. And the power supply, as we see here, is really simple. This is a transformer. And inside here you have a rectifier bridge and actually another fuse that probably stands on the DC side of the circuit. You do have some drivers or maybe power regulators. It seems like driver transistors that's actually screwed into the side of this as cooling. And you do have some microprocessors and Eeprom. Actually, you have two rectifier bridges in here, and that means that we at least have two lines of power. And we do have this one, and this one is the ones that goes to, no, that one is the ones that go to the tower, and that is actually connected with a plug, so that's possible to remove. And we do have some stepper motor over here. This is for the tractor feed and paper feed. And this one here that runs the carriage here, it's not a stepper motor. It's probably have some position gear, and you can see down here that it's a read switch for reading the 0 position on this. So there are a couple of things we have to look into, but the first thing we will do is to replace this fuse and see if that improves things. This fuse is a standard 20mm issue fuse. Oops. I have to use some glasses to read on this fuse, and it's a slow blowing fuse of 160 milliamps, I think it is, 250 volt. So I will go inside to see if I find a fuse like that. Sometimes in old electronics, when the fuse is blowing, it's because some capacitors and other things is getting a little out of spec. So sometimes when I test this, I put in a little bit bigger fuse than was originally. So I took with me 250 milliamps too, but I'm going to put in the 160 milliamps first and see how it goes. And I'm going to do a manual inspection of a couple of things before we plug this in. And these capacitors, they look nice and shiny, and we don't have anything else that appears to be burned on what we can see. But there actually is another fuse in there, so it's 2 fuses, one for each of the DC inputs. I'm going to disconnect this wire here. I at least hope I am. Okay, the whole circuit here actually disconnects like so. Okay, then it's easy to measure these fuses. That one is okay, and this one is okay. Yeah, then we see the whole circuit board here, so it's very easy serviceable and replaceable, and this looks brand new. And you can see here this printer is made by Sikorsha, that was a famous brand back in the day, and Commodore outsourced more than one of their printer designs to them. I'm not sure if the cover needs to be on for us to test this, but I can't see any switches around the edges here that appears to be checking if something is on the cover side. So I just think I'm going to leave this about like it is, then I can take this and just make it so, because we have this power LED that should come up over there. And otherwise we can just leave it like so, and I switch it off, at least I think that's off, and I plug in the plug, and I actually could hear some reaction here, and I think what I heard was the fuse blowing. It was this slight click noise. And if we measure this fuse, I'm pretty sure that it's blown. Yes, it is. And it did break straight away. And this is just a transformer. And when the transformer of this kind breaks, it normally goes into an open. But we do have some other stuff on the input here. You do have this one, that's probably a thermistor of some kind. So this is probably of noise reasons. But we are going to take out this printed circuit board, and we are going to disconnect things so that we can measure things on the input here. But as none of the fuses on this side is broken, it's probably rectifiers or can be diodes and other stuff on this side. But it's not very often that these kind of things make a short circuit when they break. They mostly fail in an open position. This fuse here should be 1.6 amps and this also 1.6 amps. And I can't see the voltages that's stated here, but I see one place here that it stated that there should be a measurement point for 20 volt. So probably there is one 20 volt winding for this motor running stuff, and there is one 5 volt winding for the 5 volt power supply. So at this point I'm just going to do some very sporadic test and measurements, and we are going to go inside and look up the schematics for this. I don't see any other screws, so I think the whole PCB is fitted through these ones. You can see that there actually is some crack here, but I don't think this is the plastic of this. I just think it's the paint here. Yes, and this has actually been opened. These screws here that fasten this mechanism to the bottom here, they have been opened before. I can see some scratch marks on the head, and that means that we probably will be fixing someone else's mess this time around too. So I just lifted this to get this plug out of the way, and this is the plug that goes into the power supply. And you know what, this is probably not a plug, and we need to really keep track of what we are doing here, because as we said, we have to capture this on camera. This one that I now mark with black on black is pin 4 on this plug down here. Yes, so this one is 4. It was the closest one to me, so you have to help me remembering that. Then we can check out this power supply. The first test now will be quite easy. I just pop in the fuse and I turn this on. Then I will see if this power brick is okay. I actually can do some measurement too, because these leads here, that's here, is from this winding here, and this is the secondary windings, and you can see this is the primary windings here. And there probably are some more windings on this that can be used if you want to use this on other voltages. So I must make sure to put my meter on AC volt, and 200 of them, and I'm going to pop in the new fuse. I could of course have just put in an amp meter here to see how much power was being drawn here, but fuses are cheap and I have to go out in the rain to get an ampere meter. Now I just turn this on and I put in the plug. I could not hear the fuse breaking this time. And this gives us 26 volt. This is one winding and this one is about 10 volt. And of course you have the outer points of this with the differential voltages. This we would have been able to see if we had the fluke scope meter, but I think this is the windings that they actually tap, and this is the 26 volt that will go inside and be 20 volt, and this is the 10 volt winding that will go and be the 5 volt winding. So this part of the circuit is okay. So the fault is on the main board or fastened to the side of the printer here. And I really hate these kind of connectors. There is really no savings with using these. And sometimes when you are frustrated and you have to make do with what you have, you just take out the connectors and you solder them straight to the board. It will make the life a hell of a lot harder for the next guy that needs to be inside here, but then you have to do a good job so we don't need to be. I'm just going to turn this around. I'm going to disconnect things from here, I think. This is soldered on, of course, but this actually is possible to take out. I made this a bit serviceable. So this was good thinking, to say Corsa, when they designed this. We have now disconnected the 220 volts, and we just have the rest here to take care of. This plastic piece, I think, is just fastened with one screw here, so I'm just going to remove that to make navigating this a bit easier. And hopefully we don't have to disconnect so much else here. From the top I can see that there are some very bad solder joints here. I will try to zoom into to this and see if it's possible to capture this on camera. This is the connector that comes from the top. If we try to wiggle this, you will actually see the movement here on these pins. So at least these pins and this pin has a very bad connection. This pin I hope is just plastic because it's not connected at all. To dial this out a bit. Yeah, this is probably the best shot I can give you on this. What we see on top here is a microprocessor, probably something that's designed just for printer controls. We have an Eeprom, and this is typically custom for each market with special letters and other stuff, and probably almost the same mainboard could have been used as part of other things, but of course the Commodore serial bus makes this special. And apart from that, you have 4 ICs here that's in the 74 series, 74 LS04, 74 LS74, a flip-flop, and you have a 7474 again. And you have the 7406 buffer, and you have a bus driver here, 74 LS373. And you do have some other electronics on this. You have this one here, that's an LB1233. That's probably a stepper motor driver, or it is a driver for the liner motor, but I think we have the driver for liner motors and stuff here. But if we look to the bottom of this construction, probably everything that's contained within here are power supply. This is a one-sided PCB by all means, because everything that's routed on top here is routed by wires, and you have a complete earth shield probably on top here. I'm going to look into the schematics to find out what we are supposed to find here. So that's it from the shed this time. I think we go back and take a session with the schematics for this and see if there are different versions and so on. And this states that this is the GP-J1, and it has you have a revision number of 12345. It's no other code that I can make any sense of. Yes, we are now back in from the shed and is going to take a look in the service manual for the MPS 801 printer that we started looking out in the shed. And all the information about this printer and that I got is from a service manual of January 1985 that actually states preliminary. And it's the only one I found that was complete online. And the specification of this printer is, typical of a low-budget printer from back in the day. And the character matrix on this is actually 6 by 7 dots, 7 dots high by 6 wide. And it can display all the pet graphic characters. And it also can print graphical modes as koala and other stuff. I actually did that back in the day and had some nice printouts up on the wall. Of course, the tones of gray was not very good, and it was really dependent that you have a good printer ribbon so that you can get even printout over a whole sheet of A4 with graphics. It's also stated that it's not compatible with the VIC-20, and that was kind of a surprise to me. I didn't know that. And the block diagram of this printer contains every piece of electronics that's in it, and you have the line feed switch, the power lamp, the dot sensor, home sensor, and everything is described here. And you also have the line feed motor, the paper feed knob, the tractor paper feed shaft, and so on. So everything is described in this block diagram. And it's a rather nice touch that I have this. I really enjoy leafing through these old service manuals. And this is how the character set are built, and this is A. And I just printed an example of a dot matrix font on the side here. This is not how this printer writes this. You can see on the double Y here it's a bit wider, but this is an example of a dot matrix font. And the printer method on this is not needle print as it normally is on this kind of mechanism. With a needle print, you don't have a hammer here. You have 9 or 24 or whatever needles that stands here and print each dot on the sheet of paper that goes through here. And this actually works like this is rotating, and it has a slight curvature. So when the line moves ahead, there is always one of these that points to the hammer. When you want to write the dots down here, this actually moves one time down here for each dot. So when you have a typical needle printer, you have all the needles that push onto this at once, but here this hammer has to push to this point here. If you have a 7 character high or a 9 line high, as you will have if you print graphics, this hammer actually have to beat against the printer ribbon 9 times for each position. And that's one of the reasons that this printer is very, very slow. The system, they call it a uni-hammer printing system, and that is different from the impact dot printing system, that is the normal needle-based systems. And as a further description of this, they say that when this turns around here, you write each line like this away. Here you're not writing a single character as you do with a normal needle printer. So you write each line here. This is P1, P2, P3, P4, P5. It's actually rotated like so, this way, of course. So each pass of a ridge causes one dot column to be printed and one slash with the hammer. And this printer actually has a self-test, and I was not aware of that. So when I saw the device selector, and I didn't really understand what the T meant on this switch, but you have the 5 and 4 as device numbers. You probably already know that the standard device number for a floppy drive is 8, but here you have 5 and 4. And when you put this in T and turn on the printer, it will actually do a self-test. And this self-test will continue as long as there is power on the printer. There is no stopping or turning this off. So the way to turn off the test mode is to turn off the power and put this switch back on the required device number and start the printer again. And they also warn us, do not operate self-test without paper in the printer. And that's a common warning on all needle and dot matrix printers, that you should not run them without paper in the printer. But I have never seen a printer actually get destroyed by doing this. but there will be a lot of ink on the rubber drum that goes behind the head, so that will smear off on the back of your sheet of paper, so it's sound advice anyway. And they actually provide us with a troubleshooting guide, and we are well on our way to actually doing this. And this is the symptom 1, the power lamp does not light. And they say the fuse F1 is blown, and we have already tried replacing it. The power switch is okay, that we have established, and the transformer is not bad. We have actually measured out these voltages here, so we do know that the transformer is okay, and that the trouble we are having is further down the line. And this is actually the circuit that we have measured out. This is the power switch, and it's the transformer, and it's the fuse. And this is the noise dampening circuit that stands in front of the transformer. But this is not quite the same as we have on our printer. There is no drossel in front of the transformer, and we only have this one thermistor, as far as I can see, in front of this. But the secondary side of the transformer and the voltages are all the same. And this is a schematic of the actual power supply. And I do wonder if there are more than one version of this power supply. I will show you in a couple of slides that we do have encountered that there are other versions of this PCB. Here it's stated that this should use a 7805 as the voltage regulator for the 5 volt. And they also say that they're using this transistor here for a serial linear regulator for the 20 volt rail. It actually seems like it stands 30 here, but it should be 20 volt that's output on the other rail. And this transistor is one of the transistor that's screwed in on the metal side of the printer. And I can't see any 7805, but the 7805 have a lot of equivalent numbers, so I will have to look that up. But this is our next step. It's identifying these test points here and establish if there are any short circuits here that we need to consider. So our next step will actually be to measure out the bridge rectifiers and as far as these test points to see if there are any short circuits. There can of course be a short circuit further back in the circuits that's drawing so much power that the main fuse blows, but that these fuses held up. But that's not very likely. So there probably are something wrong in this part of the circuit. And if the circuit is like this, that the fuse is the first thing and that it's in front of the bridge rectifiers and also in front of this capacitor, it doesn't make sense at all that this fuse does not blow, but the main fuse blows. So I don't think this is the right circuit for our printer. And this printer was made, also the brand of printer is of course Commodore, and it was made as an OEM product for Commodore. But the main printing mechanism is used of a lot of vendors, and the same mechanism as is in this MPS 801 is also used in some of Seikosha's own printers, some Amstrad printers, some Comrex printers, and Comrex actually manufactured these printers with a Commodore interface. And they also have some MSX printers with Philips. Atari has used this circuit, and a lot of other vendors has used the same mechanism in their printers. So there are a lot of other printers that do share the same kind of printer ribbon. But as we will see, there is a lot of problems with getting those ribbons. They are in stock. Some in Germany, I've seen some in England, I've seen some in Japan, I've seen some in China. I actually can order them by the thousands from Alibaba. So they are made still, but I would just want to get hold of a used printer cartridge so that I can see if things print or not. You can take and re-ink this ribbon quite well if the nylon that's contained here is in good shape. This is picture I found on the internet, and this is a totally other version of the PCB than we saw in our example. Most of it is actually quite the same, and it's the same chip count and probably the same logic chips that's used here, but the power supply is quite different. And here you can see they actually have fastened these two components on an aluminium heatsink that's fastened to the back plate. In our case, this back plate was made of plastic, but here it actually seems like this is metal. And you have the two fuses in line here. And this actually looks like a 7805 regulator, but I'm not quite sure. And you can also see that more of this printed circuit board for the transformer board is populated. You actually have additional capacitors here, and you have an inductor that stands here on the entry to the circuit, and this is a noise suppression drossel. So that is how far we got in this episode. So thanks for watching. Please hit subscribe if you want to be notified when we post new videos. And this saga is to be continued when I get some more information and probably is able to trace up ribbon for this printer. So see you in the next one.